Hello everyone. I, Mrs. Vineeta Philip, Assistant Professor in Department of Electronics and Telecommunication Engineering of AISSMS Institute of Information Technology Pune, welcome you all for my series of videos pertaining to important topics of the subject Signals and Systems for SE E&TC Engineering 2019 pattern. In this video, I would be briefing about the different types of signal. So signal types include continuous time and discrete time signals, periodic and aperiodic signals, even and odd signals, energy and power signals, deterministic and random signals. In this video, I will be explaining about the first two signal classifications in detail. Moving to the first classification, on the basis of independent variables, the electrical signals which are obtained from different transducers are classified as continuous time signal and discrete time signals. A signal which is defined at every instance of time over some time interval or which is continuous in time as well as continuous in amplitude are called continuous time signals. Here is an example of such a signal, which is a sine wave as seen. It is generally represented as x of t. The signal which is continuous in amplitude but discrete in time is known as dt signal and is generally represented as x of n. Here a dt signal is shown, which is a decaying exponential signal. dt signals can be specified by a discrete set of values. We move on to the next classification of signals as periodic and non-periodic signals. This type of classification applies for both types of signal, that is CT and DT. Periodic signals are those which repeats itself after a fixed period of time for infinite time. CT periodic signal is a function that satisfies the condition x of t is equal to x of t plus t naught for any integer value of n. Here t naught is a constant. When n is 1, the periodicity formula for CT signal is given as x of t is equal to x of t plus t naught. And for dt signal is given as x of n is equal to x of n plus n naught. The smallest possible value of t0 for CT signal and n0 for dt signal that satisfies the periodicity condition is called period of the signal. The figure as seen is an example of a periodic signal and is given as x of t is equal to a cos 2 pi f naught t plus phi, where a is the amplitude of the signal, f naught is the fundamental frequency, t naught is the inverse of f naught, and phi is the phase of the signal. On the contrary, aperiodic or non-periodic signals do not repeat itself and do not satisfy the condition of periodicity. Example of such a signal for CT and DT domains are as seen. Let us now look into a solved problem related to the property just discussed. So to find whether the following continuous time signal is periodic or non-periodic, and if it's periodic, then to find its period. For the given x of t, it is equal to cos 100 pi t plus 4 cos 200 pi t. We can divide out this input signal into two parts, say x1 of t and x2 of t. Both these x1 of t and x2 of t are sinusoids and they are periodic. And let us verify this. So taking the first sub part of our signal, that is x1 of t, from this we find angular frequency omega 1, and we know that omega equal to 2 pi f. So we get f1 as 50 and t1 as 1 by 50. Let us now take the next part of our input signal, that is x2 of t. So omega 2 is 200 pi. So f2 is 100. So t2 is 1 by 100. Now when we take the ratio of t1 by t2, we get as 2 by 1. Since the ratio is a rational number and both the numerator and the denominators are integers, we say that signal is periodic. Now to find the period of our input signal x of t, we can cross multiply. So we get t1 is equal to 2t2, which is our t0. So t0 is nothing but 1 by 50. The other way is to take the LCM of the periods of the two parts of the signal, that is LCM of t1 and t2, so which is 1 by 50. Let us now take a signal which is a dt signal and check whether it's periodic and find its period. For the given x of n, which is equal to cos pi n upon 2 minus sin pi n upon 8 plus 3 cos pi n upon 4 plus pi by 3. So here our original signal can be divided into three parts, say x1 of n, x2 of n and x3 of n. Finding f1 for x1 of n, we get as 1 by 4. So our period is 4 for x1 of n and our signal is periodic. Similarly, for x2 of n, we find f2 as 1 by 16. So our x2 is periodic with a period 16. And for x3 of n, we find f3 as 1 by 8. So our x3 of n is periodic with period 8. Knowing n1, n2, n3, cross multiplying, we find that the period of our original signal x of n is 16. Or we can find the period by taking the LCM of n1, n2, n3, which is 16. That's all for now. In the subsequent video, I would be discussing about the rest of the types of the signal along with examples. So stay tuned for many such videos. Thank you for watching.